Hello there. My name is Mr. Chuku. I am happy to be here with you. I'm here to take you on an exciting journey through the world of science. The journey continues from the last, which was about gravity. Earlier, I mentioned to you that gravity is a force of attraction that pulls together all matter, that is, anything you can physically touch. It was also mentioned that gravity is so important that without it, we will fall right off of Earth's surface and float away. It is the reason a ball comes back down when you throw it into the air, instead of just traveling higher and higher. Finally, I mentioned that gravity was not invented or created by anyone, but it was discovered. In this lesson, you will discover what it means for gravity to be absent and what happens when gravity is absent. If you are ready, let's begin. Our everyday lives involve such activities as sitting, walking, picking up things from the ground, and lying in bed. None of these activities are possible in orbit. Yes, if you have the opportunity to travel out of the planet, then you can experience what it means to be in orbit. Once a spacecraft reaches orbit, everything inside it appears to be weightless. Anything or anyone that is not tied down will float. Astronauts first feel the effect of weightlessness when the rocket engines are turned off. Straight away, they begin to feel the effect of weightlessness even while they are held down only by seatbelts. Weightlessness allows astronauts to appear super strong. They can lift objects that would be far too heavy to move on Earth. But there are some disadvantages with this. Without the effect of gravity, blood and other body fluids begin to flow towards the head. This can cause a feeling of stuffiness and headaches. With no gravity to push against it, bones and muscles can become weak. To stay fit, they have to exercise several hours each day. This allows them to recover more quickly when they return to Earth. In a shuttle or space station, there is no up or down. There is no difference between a floor and a ceiling. This can make astronauts feel sick until they get used to this strange arrangement. In a space station, you can no longer feel the effects of the gravitational pull from the Earth. Since there is no difference between up or down, food does not go down into their stomach but floats about inside you. Let's learn more about the things that happen in space. After all, that is where you will find all the weightlessness you can ever imagine. After a long day walking in orbit, there's nothing like a good night's sleep. But sleeping is a little different in space. There's no up or down, as everything becomes weightless. Astronauts can attach their sleeping bags to a wall or a ceiling and sleep anywhere, as long as they don't float around and bump into something. On a spaceship like the ISS, the International Space Station, most of the crew members sleep in their own small cabins. If there are not enough of these for everyone on board, an astronaut can sleep in one of the spaceship modules. A spaceship module looks like this. Some of the quarters are private, soundproof booths where a crew member can also listen to music, use a laptop, and store personal materials in a large drawer or in nets attached to the cabin walls. The cabin also has a reading lamp, a shelf, and a desktop. It is important that sleeping quarters are well ventilated. Otherwise, astronauts can wake up needing oxygen and gasping for air because a bubble of their own exhaled carbon dioxide has formed around their heads. More strange things happen when the effects of gravity disappear. For example, we are used to seeing a candle flame with a tapered shape like this. The pointed flame is formed when the hot gases rise, because they are lighter than the cool air that surrounds them. This cool air is drawn into the base of the candle wick and provides oxygen to keep the candle wax burning. But in weightlessness, the hot gas is no lighter than the cool air, so it does not rise. The result is a small, almost invisible round flame. The actual burning takes place only on the surface of the flame, where fuel from the candle wax can mix with the oxygen in the air outside. Scientists can learn a lot by studying the way things burn in weightlessness. This knowledge can then be used, for example, to design car or aircraft engines that use less fuel and create less pollution. Another interesting thing about weightlessness is that experimenting with it can help industries improve their inventions. For example, research areas that involve mixing liquids can benefit from this. Many of the metals in everyday use are alloys. Alloys are formed from the mixtures of two or more metals. Alloys are made by melting the metals so that they mix together. On Earth, gravity strongly affects the way the different liquid metals combine, but the mixing is much easier in space. Experiments under weightless conditions are teaching us a lot about this process, so that better alloys can be made back on Earth. There are situations here on Earth that you can feel the same thing that the astronauts are experiencing. If you have ever been on a roller coaster, you know that as it heads up and over to the top, you feel as though you're going to fly out of your seat. It is the same weightless feeling, and is due to the combination of speed and the curvature of the roller coaster as it is coming down. And yet, you are indeed falling from the top of the roller coaster. The same rules in science that apply to the roller coaster apply to the astronauts out in space. Speed, combined with falling towards something that is curving away, can seem like weightlessness. If there are two objects, such as a space station and an astronaut, and they are both going at the same speed, it will appear as if neither is moving, and yet both are weightless. That was interesting, right? Now, let us remind ourselves some important things we learned in the lesson. A. Once a spacecraft reaches orbit, everything inside it becomes weightless. B. Weightlessness allows astronauts to appear super strong. C. Without the effect of gravity, blood and other body fluids begin to flow towards the head. This can cause a feeling of stuffiness and headaches. Amazing! We've learned something new today, and it was about gravity. But just before we finish up this lesson, let me ask you some questions. They will help you remember things even more. 1. What happens to the bones and muscles when there is no gravity to push against it? That's correct. With no gravity to push against, bones and muscles can become weak. 2. How can the environment look strange and make astronauts feel sick once they are in space? You are absolutely right. There is no difference between a floor and a ceiling. This can make astronauts feel sick until they get used to this strange arrangement. Wow! Thank you for spending some time with me in this lesson. It was fun learning something new. In the next lesson, we will learn more interesting things. Until then, bye for now.